Hello everybody, and welcome to the beginning of section 6.4. We are looking at page 42 of the workbook, and the topic of this section is physics applications. In particular, applications of integration to physics problems. Okay, and to keep this discussion shorter, we're just going to restrict it to the idea of work. There are actually a lot of other physics applications that we could talk about here. Okay, and before we get into the details of how we calculate it, I'd like to glance down at this example at the bottom of the page here and just read this problem so we can get a feel for what this type of a problem sounds like. So suppose we have a rock climber with a mass of 60 kilograms. If she climbs a vertical distance of 100 meters, how much work is done against the force of gravity? Okay, so calculating work is basically about two things. It's about a force that we're trying to move against and a distance that we're moving against that force. Okay, so we come up to the top of the page, preliminary facts about work. That's going to be our very first formula. Work in its most basic form is just force times distance. Okay, and in this section, we're going to restrict our discussion to just one type of force, and that is the weight. We'll be talking about the work that we do in moving objects of a particular weight. Okay, so weight by definition is just the force that gravity exerts on an object of a particular mass, and we can calculate weight by taking mass times the acceleration of gravity. Okay, these first two formulas, if you've ever taken a physics class, you probably have seen these in some form or another. Okay, then the next thing we'd like to talk about is what sorts of units do we measure these things in? Okay, and we'll start with metric units. Those are by far the most important ones. So how do we measure mass in metric units? Well, there are different ways, but one unit would be a kilogram. Okay, you could also do it in grams or other units, but kilograms may be kind of the standard unit for mass. What about force? Okay, well, force is about taking a mass and multiplying by an acceleration. So if we break the units down, they would be kilograms times meters per second squared. Because that comes up so often, we give it a special name. It's called a Newton. Okay, a Newton is 1 kilogram times meters per second squared. Okay, and then we come to work. Okay, work is force times distance according to that formula up there. So we want to take force, which is measured in newtons, and multiply it by a distance, meters. And newtons times meters has a name. It's called a joule. Okay, so we've got kilograms, newtons, and joules for these three quantities. Okay, now, as I said, metric units are by far the most important ones, but English units do come up sometimes. Okay, we live in a country where they're still used occasionally. So we're going to kind of de-emphasize these, but I'm going to mention them just so that we've got them in front of us. Let's start with force. So when you step on your scale, what units do you usually see? Okay, you see pounds, and that's kind of one way that you could measure force using English units. Okay, work again is about taking a force and multiplying it by a distance. Okay, so the typical unit of work is foot-pound. That sounds kind of strange. Seems like there ought to be a better word for it, but that's the unit that's generally used. And then probably the strangest out of all of these, what is the English unit of mass? Okay, this may be the first and the last time you ever hear this word. It's called a slug, mass in slugs. You're going to think I'm making that up, but I'm not. Okay, and like I say, we are not going to mention that unit ever again, but just for completeness, we'll put it on our table here. Okay, so now that we kind of have the groundwork in front of us here, let's see if we can do this example down below. Okay, so here's the rock climber again that we mentioned at the beginning, 60 kilograms. We want to measure the work that it takes for her to move up 100 meters. Okay, so we can see up above that work is force times distance. So we need those two pieces. Let's start with the force. The force that we're going to be talking about is her weight. So we need to start by calculating that. Okay, so we'll take the hiker's mass, 60 kilograms, multiplied by the acceleration of gravity, which happens to be 9.8 meters per second squared near the surface of the Earth. Okay, so when we talk acceleration of gravity, we'll always be using that 9.8 number. Okay, if we multiply those, we're going to get 588, and units are kilograms times meters per second squared, so we've got newtons there. Okay, and let's remind ourselves that that's the weight of the climber. Okay, so what we've just calculated is the force, basically. That's the weight. So to get the work, we just need to take that force times that distance. Work equals force times distance. Force is 588 newtons. And the distance, we can see we were given in the problem, 100 meters is the distance that she's going to climb. So we're going to take that times 100 meters. And we come up with a number that looks like 58,800. And what would the units on that be? Okay, well, we've got newtons times meters, and we talked above about how our name for that unit is a joule. Okay, and so there is the amount of work that's done.